In this video, we're going to take a look at question 9 on practice exam 3.1 from the fall 2021 semester in Chem 1211. And the question is, which statement best explains why the sulfide anion, S2-, has a larger radius than a neutral sulfur atom, S? So, first of all, particularly since one of the options is, hey, this is a trick question, S2- does not have a larger radius than S, let's get those ions down and convince ourselves that S2- is, in fact, larger than S. There are a few different ways one can do this. The way I tend to think about it in sort of qualitative terms is in terms of electron-electron repulsion. I have more electrons in the S2- anion than I do in the neutral sulfur atom. S2- is essentially sulfur with 2 additional electrons, and so there is greater repulsion between electrons here, greater electron-electron repulsion. And this is going to tend to enlarge the atom or ion, right? As we add electrons to it, the electrons repel one another, the atom or ion gets bigger. And another way to think about this that's equivalent is that the effective nuclear charge is smaller. The effective nuclear charge is smaller for S2-. And this is because we have additional electrons in the valence shell. The new electrons, as we add electrons to a neutral S atom, go into the valence shell, cause shielding, contribute to shielding, and this lowers Z effective relative to Z effective in the neutral sulfur atom. So Z effective is smaller for S2-. So even before I've looked at the choices, I'm already thinking here about reasons why S2- is larger than S. And of course, in order to rule out, again, this option, we want to start thinking about those reasons. So now let's go through the choices and see how they jive with what we've already demonstrated here. So first of all, there's more electrostatic attraction between the valence electrons of S2- and its nucleus than between the valence electrons of S and its nucleus. Well, that's inconsistent with Z effective is smaller for S2-. The attraction of the electrons to the nucleus is weaker in S2- than it is in S. So that is false. S has fewer core electrons than S2-. Also false. The new electrons in S2- get added to the valence shell. This is a bit behind where we are in lecture right now, but if we were to draw Lewis symbols for these two species, S2- would look like this with 8 valence electrons, and S- would look like this with, neutral S would look like this with 6 valence electrons. And clearly the number of core electrons is the same in both of these. The number of core electrons is really built into this atomic symbol, S. So, number of core electrons are equal in the two species. S2- does not have a larger radius than S, we already ruled out. S2- has a more positive nucleus than S. Well, clearly that's false since they're both sulfur, right? And so both of these species have the same atomic number, the same number of protons in the nucleus, and the same charge in the nucleus. There is less electrostatic repulsion in the valence shell of S than for S2-. Well, that's true. That's true. We have additional valence electrons in S2- relative to S. And this means that we're going to have greater electron-electron repulsion within the valence shell of S2- relative to S. Let's convince ourselves, though, that the last choice is false. Z effective for S2- is greater than Z effective for S. We actually already showed that that is false. Z effective is smaller for S2- than it is for S. And so, again, by default, the correct answer here, there's less electrostatic repulsion in the valence shell of S than there is for S2-. And again, you can almost see it in the Lewis symbol, right? The electrostatic repulsion associated with these 8 electrons in the valence shell of the S2- anion is going to be greater than the electrostatic repulsion among the 6 valence electrons in a neutral sulfur atom.